Now let us take care of this question. Now the question says the fundamental frequency of a plucked wire under a tension of 400 newtons is 250 hertz. When the frequency is changed to 500 hertz at a constant length, the tension is. Now, if you can solve this question, you can pause this video and you go on, okay, and solve it. But if you cannot, then you continue. Or I would like you to like pause the video and attempt the question. So now, the fundamental frequency of a plucked string F1, okay, is equals to what? V over 2L. Now, velocity of waves on a plucked string is equal to square root of what? Tension over mu, where mu is what? Mass per unit length. That is, this mu now is equals to m over L, okay? This mu, m over L, mass per unit length. Now, let us go on. Now, if you substitute for V here, we now have F1 is equals to what? 1 over 2L times square root of what? T over mu. This is it. So you know that this tension is varying. There is a variation in tension. So we have it as T1. This is the first tension. Okay. So the second tension will be, the second frequency will be, see here, frequency and tension, they are variables. Do you understand? So they are varying. So F2 is also equal to what? A V over 2L. You might be wondering why I still have this F2 as V over 2L. Remember, if the tension is increased, the frequency will increase. See, the wave, the mode of vibration will look like this. It will look like this. You see it now. So remember that this is the fundamental frequency. Let me draw this thing here. This is the fundamental frequency, remember. So the wavelength here and the wavelength here, they are not the same. Do you understand? So we are like considering a part of this mode of vibration, the smallest part of this mode of, a part of the mode of vibration. Do you understand? So this is it. So now, this part and this one and this one, they are not the same. This one is bigger than this one, okay? They are of different frequencies. Good. So we are talking about here. So my F2 will be V over 2L. I'm talking about this one. Correct. That is if this one is to be a fundamental frequency for this mode of vibration. So let's continue. Now, we have V over 2L equals, that is V over 2L times, 1 over, V is, that is, my V is, root of tension. So which is, I will now say F2, that is, which is equals to 1 over 2L times what? Square root of T over mu. That is, in this case, it will be T2 over mu. So look at it now. So now when we now do F1 over F2, we now have equals to, which is 1 over 2L times root T1 over mu, all over 1 over 2L times what? Root T2 over mu. So which implies 1 over 2L will cancel. They will cancel out. So this one will be, I don't want to just write the answer. I can do that, but, I just want everybody to be following up. So now we have F1 over F2 is equal to, that is square root of T1 over square root of mu. Okay. Then all over square root of T2 over square root of mu, which is equals to root T1 over root mu times root mu over what? Root T2 over root T2. So mu will cancel mu. So we now have, finally, F1 over F2 is equal to root T1 over what? Root T2. So you see, we have gotten the equation to solve this. Now, they now say, with this equation now, you can now input the values. So F1 is what? 250. So we now say 250 over, we are looking for, okay, we are not looking, they give us F2. So it's the tension that we are looking for. So F2 is what? 500 Hz. 500 equals to T1 is the first tension is what? 400, square root of 400 all over root T2. So we are looking for T2, you see. So now we have, which is equal to, 252. What that is 250, that is 1 over 2. 250 over 500 is 1 over 2. So 1 over 2 is equal to, root 400 is 20. 20 over root T2. Good. So we now cross multiply. We now say root T2 is equal to what? 2 times 20, 40. Okay? Therefore, T2 is equal to 40 squared. Therefore, T2 is equal to what? 1,600 newtons. So this is clearly the answer to the question. I hope it's very, very clear.